This is the homework video guide on prime factors, and for the very first question we need to determine the number of factors, the total number of factors of the given whole number. So the very first whole number that's given to us is 8. Okay, and all we need to do now is determine the number of factors. So we need to look for numbers that multiply to 8. So there's a few ways you can do this. You can start off with the lowest number, which is 1. So 1 times what will give you 8? And that's going to be 8. Another combination that multiplies to 8 is 2 and the number 4. And that's going to be it. 1, 2, 4, 8. So these are all the factors, and since there's 4 of them, we will conclude by saying that there are 4 factors. Okay, so all these numbers that I'm highlighting in yellow, these are the 4 factors, and all those numbers divide evenly into 8, and that's why they're called factors. For letter B, the whole number that's given to us is 11, and this is a prime number, and there's only one combination that I can think of in terms of numbers that multiply to 11. That's just 1 and 11. So if I just kind of draw like a tree diagram here, two numbers that multiply to 11 are 1 and 11. So there are 2 factors here. 2 factors. So the factors are 1 and 11. So both of those numbers divide evenly into 11. Okay, let's take a look at a different number, 45, which is a little bit more interesting than a prime number here. So our whole number now is 45, and let's think of the numbers that multiply to 45. We can start out with a low number like 1. 1 times 45 is definitely 45. And then if we move up the ladder here, the next number is going to be 3. So 3 times 15 is 45. And then we also have the number 5. 5 times 9 gives us 45, right? So if I count up all these numbers here, 1, 2, 3, 4, 5, 6, we can say there are 6 factors here. All right, so these are the 6 factors evenly divide into 45 here. Okay, let's move on to question number 2 here. For question number 2, I need to list the factors of the following numbers and determine all the factor pairs. Okay, so since I need to write out the factor pairs, I'm going to just write my answer a little bit differently here. So I'm going to start off with the number 1. So 1 times what gives you 21? Well, that's 1 and 21. And then another combination that's definitely going to work is going to be 3. 3 times what will give me 21, and that's 7. All right, so there you go. Those are my factors. So my factors are 1, 3, 7, and 21. So these are my factors. And my pairs are the numbers that kind of multiply to 21. So 1 and 21, that's one pair, and 3 and 7. These are called the factor pairs. Okay. So very similar to what we did in the first problem. If you want to kind of write out the numbers in a horizontal format here, you could write 1, 3, 7, 21, just like we did in question number 1. And then you can just write your pairs as 1 and 21 and 3 and 7, right? So that's another way where you can represent your work. Okay, let's move on to 36. Okay, so factors of 36. The smallest number is always going to be 1. So 1 times what will give you 36? Well, that's going to be 36. Then 2 times what will give me 36? That's going to be 18. And then 3 times what will give me 36? That's going to be 12. And then 4 times 9 will give me 36. And finally, the last factor pair is 6 times 6. All right, so these are all the factor pairs. So that's a pair, that's a pair, that's a pair, that's a pair, that's a pair. And if I want to write out the factors, I would just write them out one by one. So 1, 2, 3, 4, 6, then 9, then 12, then 18, and 36, right? So these are all the factors right here. And these are all the pairs. Okay, so I think we're aware of doing this kind of work. We're just kind of introducing the vocabulary here, right? Factors and factor pairs. Okay, let's move on to the next homework question here. So I need to classify the following whole numbers as prime or composite numbers. Okay, so we have a list of whole numbers here. And let's go ahead and see if we can identify the numbers as being prime or composite. Well, definitely letter B is going to be prime. And C is going to be prime. And 30, for example, is composite. And it's a composite number because you can find numbers that you can find a few pairs, factor pairs that multiply to 30. For example, like 6 times 5 and 3 times 10. Right, so as soon as you have a combination of numbers or pairs that can give you the number 30, we call that a composite number. The reason why 41 is prime is because the only pair that works is 1 and 41, right? 1 times 41 is 41. That's the only combination that works. And 1 times 43, that's the only combination that works for 43. So that's why we declare B and C prime numbers, where 30 is a composite number because we can find several combinations. Okay, let's move on to letter D here. Letter D is going to be a composite number here, comp. And one of the numbers that, a combination that works is 3 times 19. And there's also 1 times 57, right? So we found 2 different pairs, so that's a composite number there. 59 is a prime number. 11 is a composite number here. So we have 11 times 11 and the classic 1 times 121. This is going to be 133 is a composite number, so we have 7 times 19. And we also have 1 times 133. And then H is going to be a composite number as well because we have 13 times 13, and we also have 1 times 169. All right, so if you can find at least 2 pairs, like I'm highlighting here in yellow, these are considered composite numbers. And if we have cases where there's only 1 pair, those are the prime numbers, right? So this will be a 1 times 59. All right, so there we go. That's the difference between prime and composite numbers. Okay, let's keep on going through. Now I need to state the prime factors of the next few numbers here. So, well, when we look at the 15, the factors of 15 are 1 and 15, and then we also have 3 and 5. Okay, now out of this list here, the prime factors are 3 and 5. So, the answer is just 3 and 5. These are considered the prime factors. Okay. 1 by definition is not a prime number, right? And 15 is a composite number. So out of that list right there, the prime factors are 3 and 5. Okay, now although that's the answer here, another way that you can kind of show your work for these kind of questions is by drawing a tree diagram. So for example, we have 3 and 5. And we can just conclude that our answer is 3 and 5. Those are the prime factors, right? So, I mean, we can't really break this down any further. We know that the ones aren't prime numbers here, right? So once you get to a prime number, so this is a prime number and that's a prime number, we can just use this tree diagram and conclude that 3 and 5 are the prime numbers here. Okay. Another way where you can use a tree diagram for question number 20 for letter B here is find 2 numbers that multiply to 24, for example 6 and 4. And then since 6 and 4, these are not prime numbers, you can continue to break them down as 3 and 2 and 2 and 2. And now you can see that all of these numbers below are prime numbers, so the prime factors are just 3 and 2. Okay. When we have 45 here, I guess we have 9 times 5. And we would continue breaking down the 9 because this is a composite number, so you have a 3 and a 3. So I would say that from this list of prime numbers here, the prime factors are 3 and 5. So 3 and 5 are the prime factors. So overall, we're looking for numbers that divide into 45, but we want to list the numbers that are prime. And that's what this question is asking us to complete here. Okay, let's move on to the next set of questions here. Question number 10, use a division table to express the prime factorization of the following using powers where appropriate. Okay, so let me introduce this concept of a division table here. So the whole number that we have is 140. And the way I do a division table is I write out the number 140, and then I draw this sideways L here. Sometimes I call this the ladder method. And we want to think of numbers that divide into 140, and usually I like to start off with the smallest number possible, and since 140 is even, I'm going to use the number 2 here. Okay, so 140 divided by 2 is going to be 70. Okay, and then I keep on breaking down the number here. So what's another number that divides into 70? Well, I'm going to use 2 again, and 70 divided by 2 is going to be 35. Okay, now I need a number that divides into 35. 2 no longer works, 3 doesn't work, so the next number that works is going to be 5, and 35 divided by 5 is going to be 7. Okay, and as soon as we have a prime number here, this is where we want to stop. Okay, so what we're going to do now is we're going to write our answer using prime factorization, and we're also going to write our answer by using powers where appropriate. So what we're going to say here using this division table method is that our original number was 140, and what we're trying to say is that all these numbers on the outside here, 2, 2, 5, 7, if I write out those numbers on the side here, 2 times 2 times 5 times 7, these are all the factors for 140. And if I want to write my answer using powers here, I know I have 2 times 2, so that's going to be 2 to the power 2 times 5 times 7. And this answer right here, this is called the prime factorization right here. Okay, so what we're trying to do is, if I have the number 140, I can write that using this concept called prime factorization, and I'm illustrating that using this division table method here. All right, great. Let's keep on practicing this concept again. I have another one, letter B here, 330. Okay, so if I'm using the division table method, I usually take my whole number, which is 330, and then I create a sideways L for the division table, and then we think of numbers that divide into 330. Now, just like in my previous example here, I'm going to start off with a very small number like the number 2 because 330 is an even number. And what's 330 divided by 2? Well, that's going to be 165. 165. And then I need a number that divides into 165. 2 won't work, so how about we use 5? If I use 5, I get 33 now. And then I need a number that divides into 33, and a number that works there is probably going to be 3, so 3 and 11. And this is where I'm going to stop because 11 is a prime number. And then I can kind of conclude by saying that 330 is going to be equal to all of these numbers in green, all these prime numbers being multiplied. So I have 2 times 5 times 3 times 11. And that right there is called the prime factorization of 330. Okay, let's keep on going here. Okay, so for 10D, I have a bigger number, 1,925. So I'll take my whole number, which is 1,925. And then I will create this sideways L because the question is asking us to use this division table method. And since there's a 5 here, I'll probably start by dividing this whole number by 5. So 1,925 divided by 5, I'm going to use my calculator here and I get 385. And then the question is, can I think of a number that divides into 385? Well, let's use 5 again. So 385 divided by 5, that's going to be 77. And now we're in a little bit better state here because we can use the number 7. 7 definitely divides into 77, and now I get 11. And this is where I stop because 11 is a prime number. And if I just kind of continue to work over here, 1,925, this is really equal to 5 times 5 times 7 times 11. So all these numbers here, all these prime numbers are all the factors here. And if you want to use powers here, notice that there's 2 5s there, so you can write this as 5 to the power 2 times 7 times 11. And there's your prime factorization of 1,925. Okay, let's keep on going here. For question number 11, same kind of concept, but now they want us to use a tree diagram to determine the prime factorization of the following numbers. So I have 390. So if you're using a tree diagram, the setup is a little bit different, but it's still the same concept. Think of two numbers that multiply into 390. I'll start out with the number 2 again. So 390 divided by 2 is going to be 195. And then think about 195. Think of two numbers that divide into 195. Well, I'll use 5 here and 39. And then with my 39, are you able to break that down a little bit further? You can. So 39 divided by 3. So now I have 3 and 11. 3 and, not 11, 3 and 13. 3 and 13. And this is where I'm going to stop. So all these numbers here, these green numbers that I'm highlighting, those are all the prime numbers, all right? So as soon as you have a prime number, you will stop with the tree diagram. Basically, the tree diagram only works on composite numbers here. So if I want to finish off this answer here, the number was 390. And then if I want to write that using a prime factorization, I would write this as 2 times 5 times 3 times 13. Okay, so there's my answer right there. And that's called prime factorization. Okay, let's move on to another problem here. 546. So we're using the tree diagram now. So let's find two numbers that multiply into 546. Well, I have 2, and this will be 273. Now with this 2, I'm going to stop because that's a prime number, but 273 is a composite number, so that means I continue breaking it down. So 3 times 91 works, and 3 is a prime number, so I stop there, but 91 is a composite number because I still have 7 times 13. And this is where I stop because 7 and 13 are prime numbers, right? So my tree diagram is done. And then I can kind of finish off by saying 546, if I break this down into its prime factors, it's 2 times 3 times 7 times 13. Right? And you can definitely feel free to verify that using a calculator, and I can tell that that is definitely the right prime factorization there. Okay, let's keep on going here. Question number 12, in each case, write the number as a product of prime factors. So this is basically the same question as questions 10 and 11. You get to decide what method you like to use. I'm going to use the ladder method here, but you can also use the tree diagram method. You'll get the same answer here. So a number that divides into 189 is going to be 3, and 189 divided by 3 is going to be 63. And then if I keep on using my division table here, a number that divides into 63, I'm going to use 7. So 63 divided by 7 is going to be 9. And since 9 is a composite number, I keep on going. And so 3 will definitely divide into 9. So 9 divided by 3 is going to be 3. And this is where I'm going to stop because that's a prime number. So 189, I'm going to look at all these numbers here. So if I use all those numbers there, I pretty much get 3 times 7 times 3 times 3. And then if I'm using the power constant here, I have 3 3's there, so I can write that as 3 to the power 3 times 7. And there's my prime factor. There's my product of prime factors right there. Okay, so we move on to question 12C now. Okay, a bigger number here, 4,235. So let me start off by writing 4,235 on the side. Let's create a ladder here, a sideways L, and let's go ahead and use the division table here. Now, since the last number here is a 5, you might want to start off by dividing this big number by 5. So 4,235 divided by 5 gives you 847. Okay, and after that, I'll just by experience here, I'm going to divide this by 7. So 847 divided by 7 gives me 121. And then now I'm in a better state here where 121 divided by 11 gives me 11. And this is where I'll stop because that's a prime number. So 4,235, if I break this down into its prime factors, which are the green numbers, that's going to be 5 times 7 times 11 times 11. And notice that I have 2 11s there. So this will be 5 times 7 times 11 to the power of 2. All right, good. I think there's one more question to go, and then we're done this homework video guide here. So the number 686 can be expressed as a product of prime factors in this form. And I need to find the value of p plus q plus r. Okay, fantastic. So let's start off with 686. And this can be expressed as a product of prime factors. So let's go ahead and use the ladder method again. A number that divides into 686. It really doesn't matter where you start. You just have to make sure the number works. So I'll start off with number 2 because 686 is an even number. So 686 divided by 2 is going to be 343. Okay, and then a number that divides into 343 is going to be the number 7. So 343 divided by 7, that's going to give me 49. And that's nice now because 49 divided by 7 gives me 7. And then this is where I can stop because this is a prime number. So here are my prime numbers. So let's go ahead and jump to our final answer here. The prime factors are 2 times 7 times 7 times 7. And since we have 3 7s, this will be 2 times 7 to the power of 3. And then if I just line up this this p times q to the r, let's just put that below here. This is p times q to the r. All we have to do is just line up the numbers with the letters. So I can see that I can see right here that p equals to 2. Clearly I can see that q equals to 7. And finally over here I can see that r would equal to 3. Okay. And then the question is asking for the value of p plus q plus r, right? So we're going to add up the values of p plus q plus r. So if I add up 2 plus 7 plus 3, I would get 12. All right, so once again, this is p plus q plus r equals to 12. Okay, so that's it for this homework video guide on prime factors.